Hello guys, in this video I'm going to show you how to solve k smallest number in a sorted matrix. Right? Given an n times n matrix where each row and column is sorted in ascending order, find the k smallest element in the matrix. Right? So, for example, with this matrix, right? It 3 times 3 matrix, right? And as you can see, each row of the matrix is an ascending order array, right? And also each column is sorted in ascending order. So k is 5, so we need to find the fifth smallest number out of this matrix, right? So as you can see, the fifth smallest number is 7 because smallest is 2, right? Next one is 3, next smallest is 3, 5, 6, and 7 is the fifth smallest number. So if we consider this this matrix, if we consider each row of the matrix is in a separate array, then our problem is the same as the one that we previously solved, which is not sure if this is the one. Here it is, that's right. So same here, given m sorted arrays, right? The only difference is that here it's separate here it is separate as a list of arrays is actually the same as a matrix, right? So find the k smallest number among all arrays. So it's pretty much the same, as I must say, right? One thing to notice here is that this matrix is each column is also sorted, right? So if we use the approach of the previous problem, I'm not gonna go into details. Let's try to run it manually. So 2, 3, 5. So as you can see, is among all the rows. So the smallest number of the array must be in the first column, right? Because each row is sorted in ascending order, so the smallest number must be one of the first three numbers, right? 2, 3, and 5, right? So the idea here is that at each iteration of processing, I want to check the n candidates, right? So if our matrix here is 3 times 3 is n 3, so we want to check three candidates. We want to compare three candidates at each iterations, and in order to get access to the smallest number, I'm going to use a min heap. Min heap. I first add it to 2, 3, 5, first three numbers, right? So you can easily get access to the smallest number, which is 2, right? Okay, let's save it. 2 is the smallest number, right? So here is the smallest number. So after that, I will remove 2 from here, right? We want to bring the next number, the next candidate, to the min heap, right? Which is the number right after 2. That is 6 here, right? So now the smallest number is 3. 2, 3. Okay. So I will remove the smallest, the 3, because it's the smallest number. What number 2 will be the next candidate, which is the one right after 3, right? Which is 7. So 5 is smallest. Okay. 5 is smallest. I remove 5 and add the next right after 5, which is 8 to the min heap. The smallest number is 6. I remove 6 out. 7, 8. What is after 6? 8 here, right? So now the smallest number is 7. Whoops, sorry. Add 7 to the next smallest number is 7. So now, as you can see, 7 is the 5th smallest number, which is what we need here, so we just return 7. So that's how we find the smallest, the case smallest number in the matrix, right? Pretty much the same as the problem we've solved previously, right? We notice that this is just one approach. There can be another approach, because there's one little detail that we haven't used in this approach, which is the column is sorted, right? This characteristic is something that we haven't used yet, right? So, but it's fine as long as we solve the problem that return the correct result is fine. Okay, let's try to code it out. We need a min heap, right? Wait a minute. Okay, we need min heap first. It's a new heap. Initialize empty, right? No. And the third argument will determine whether it is a min heap or max heap. So assume that we're adding numbers directly into the min heap. Then A and B will be the two numbers. I'm gonna return B minus A, so it will be a min heap. But do we really add the number to the min heap. As you can see, as we go through the program manually, as we popping out an item from the out of the min heap, we need to know the next candidate, which is a number right after the number we pop out, right? For example, here the smallest initially 2, 3, 5, the smallest is 2. We pop 2 out of the min heap, right? So the next candidate to be pushed to the min heap is 6, which is right after 2. But how do we know that? How do we know? How do we locate the next number? How do we locate the next candidate? So it means that we must store not only the value but the other informations as well, such as the row index and the current number index, right? So that we can find the next number. So for example, here the row index is 0 here. The current index is 0. So it means the next candidate will be at the same row index, but the number index will be the current index plus 1, right? So we got 6, right? So it means I will abstract out the item to be pushed to the min heap is a node, right? Constructor, we need value, the row index, the number index, right? So I will just okay. So we got a node here. So now the first step is we need to modify this line because A and B is no longer a number, so we need to compare the value. A and B is are both nodes, right? So we need to compare the value. So next step is to initialize our min heap with the first number, the first value of each row. So in order to do so, I'm going to use a for loop. Let of I'm going to use we need the value and the index, right? The row index and the row. So the magic dot entries will give us row index and the row itself. So I'm gonna add to the min heap, right, a new node. The value is the first number of row, which is row index 0. The row index will be row index. The number index will be 0, right? Just want to take the first number of each row. Okay. Next step is I want to get into a loop, right? I want to get into it as long as our min heap is still, the length is still greater than 0. Then I want to find the next. I want to pop the next smallest number out of the min heap, right? So we only want to find k number, k smallest number, right? So let's use a counter. Let's say from 0 right here. So after a pop the node L, let's say node L is min heap dot pop, right? So at a pop the next smallest number out of the min heap, I will increment I by 1, right? I is the number of smallest, the number that we've counted, right? So when I equal to k, it means the node L is a k smallest number, so I return node L dot found, right? This can be shortened down into plus I, increment I first, then compare value of I with k. So next step, at the top I out of the next smallest number, next node out of the min heap, right? We need to add new candidate to the min heap. So the next candidate will be the number right after node L. How we can say, how we can find? We can find thanks to the information that we have in the node here. So let's extract it out. Node L. Okay, we need row index and num index. Okay. So okay, row index. So the row will be matrix at row index, right? So we only want to add the number if it is not the last one, right? For example, the current number is 6. We can add 8, right? But if the current number is 8, we don't want to add the next one because it's out of range. So only if the num index current numbers plus 1, the next one is still less than the row dot length. Okay, then I'm gonna I'm gonna add the new one to the min heap. Next one, add a new node. Value will be a row, same row, right? But at the next index, which is num index plus 1, the row index will be row index. The num index will be num index plus 1. Okay. Yeah, so that's it. We add the new one. Come back here. So next iterations. Pop one now. And repeat the same logic here. So if it is I equal to k, it means with the k smallest number, so we return here. Otherwise we return because the mean heap is empty, right? So in that case I'll return null. We couldn't find that, right? So let's run the test. So it works. So that's it for this video. Thanks for watching. See you in the next one.